good morning, good afternoon, or even good evening, depending what time zone you are in. Now we will take a look on S2D simulation using WSLab. I would like to demonstrate what's possible and what is not. My name is Jaromir, I'm Premier Field Engineer in Microsoft, and you can follow me on Twitter. And I promise I will post only WSLab related stuff. The objectives now are to learn what the WSLab is. I would like to demonstrate and show what can be simulated with WSLab and what is possible and what is not. To introduce myself, I've been in Microsoft for 7 years now. I'm a PFE there, means we will go on site if there is any problem, or we can help remotely to our precious customers who pay for the Premier support, or who have a Premier contract. We do this by going on site. We do chalk and talks, even workshops. I share all my experience on the GitHub, so you can get some kind of taste of Premiere. I authored the WSLab, and to mention the history about that, it started all like 4 years ago. These kids were much smaller. This is like 1-year-old photo. My kids are now 6 and 3. I'll be 7 and 4 soon, and we are expecting the third one. So I guess it will be fun, but no worries. There will be still room for WSLab to actively develop it, as I did. So what is WSLab? WSLab is basically a bunch of scripts and scenarios hosted on the GitHub. It means that you can go there, you can download something, some zip file, which is on the link on the first side, and you can extract it and deploy that, and pretty easily, and I will explain the process on the further slides. What it can help you with is, instead of having a huge pile of servers like on the picture on the left, you can have only a small Surface Pro 2. And the Surface Pro 2 on this picture, as you can see, it's running a bunch of the virtual machines. And there are actually 5 of them powered on, and these 5 machines are simulating DC with SCVMM installed, and even there is a 4-node S2D cluster. It's tiny, super small here, but on the picture you can see SCVMM console with cluster and with 4 servers. It will make your laptop scream, I'm kind of serious. If you spin the lab, it will start to be loud, especially if your machine is some small laptop with this, I would say, spinning razor. Well, it can be really noisy because you will be utilizing your CPU to 100%. But in return, it will change your life, because instead of having the pile of the servers that are noisy, and if you have it in home, you probably have problems with your wife, and I think everyone knows that. So you may want to transition to something more silent, more compact, and this is like ideal, because you can have just a small laptop, or even you can have a workstation or something like that, and it can simulate entire infrastructure. If you can't afford to have any machine, and I believe you can afford something, right? You can also run WSLab in Azure. The way it works is that you can navigate to WSLab portal, and in WSLab there are scenarios. In one of the scenarios is running WSLab in Azure. If I will describe the GIF that is demonstrated here, I didn't do any demos, because it's kind of, we have only 30 minutes. So what I did, I recorded these GIFs, and it's running in the loop. And you could see that when you will navigate into the scenarios and in the GitHub page, you will click on deploy on the scenario called running WSLab in Azure. You will be prompted with this form where you will just fill in the passport and also the resource group, and you will just click on deploy, and it will create you a VM with, for example, here Windows Server 2019. This VM will have Hyper-V enabled, and also scripts will be downloaded to temp folder. So only thing you will have to do is to run 1, 2, 3 in the scripts. Download, of course, you will need to download the images, but it will be really fast since you are located in Azure Data Center. So this is also really convenient, and it's really useful, for example, if you need to work with the customer and have lab machines for him. So you can do it the way that you can spin like 10 VMs in Azure and give customer access. So what is this? What are the scripts? Scripts can be downloaded from the GitHub page. There is a zip file link. You can just download it, extract it into some folder as demonstrated on this screen on the left. Then you will have 5 scripts, and once you will right click on first one, select Run with PowerShell, it will create some folders and download some prerequisites, and then you will just run the second script. The second script will prompt you for ISO file, cumulative updates, and so on, but this process is described on WSLab GitHub page. It will take around 90 minutes. It will build up a domain controller, and it will also build parent images. These will be just, the domain controller will be then just imported and deployed, and it will take much less. If you have an offline environment, you can just run first script. It will download everything, so you can run it on internet connected machine. Then you can grab all the files, copy it into the offline machine, and run again first script, then second script, and you will be good to go. Because all the tools that are downloaded, if it's already present, it will be skipped, so no internet connection is needed. So the second phase, as I already described, is only importing domain controller. What it will do, it will import domain controller and create machines as described in the lab config. As you can see on the screen, it's pretty fast process. If you take a look on the uptime, you can see the number is growing pretty fast because this is fast forwarded. So it's running much faster than in real time because this process takes around 5 minutes. So this is time compressed. As you can see, machines will be provisioned. There is a prefix, in this case it's WSLab 2019.292. This is just a version I maintain. You can name it as you want. The default one is just WSLab. And as you can see, these 5 machines were provisioned in around 5 minutes. The main differentiator between this and other project is that this is lightning fast and ultra compact environment. As you can see on the left, these virtual machines are not consuming many resources. The assigned memory for the DC is 1300 megs, while for the VMs itself, I mean these S2D VMs, these are just 600 something megabytes. If you take a look on the size on the disk, as you can see, it's around 50 gigabytes. This is because also there is a Windows 10 image there, so it can be even like 40 gigabytes only, while size on the disk is only 4.6 gigabytes. This is possible because of the duplication. If you will use the duplication, it will significantly save the size on the disk. So this is preferred. Just one note about the duplication, you need to run it on separate volume. So you cannot deduplicate the volume where operating system is sitting. So I recommend you, like in my case, I have a 500 gigs disk in my laptop, and I split it so I have 200 gigs for operating system, and the rest I have for the VMs. And you can save a significant amount of the storage. In my case, I have like 5 labs, like 2019, 2016, 2019 Virtual Machine Manager, 2016 with Virtual Machine Manager, multiple images, and so on. and it consumes around 100 gigs. And my record was I saved like 700. Let's talk about scenarios now. What are the scenarios? These are a bunch of end-to-end configurations for different technologies like storage spaces direct or storage replica or even traditional Hyper-V with SUN. I also demonstrate their running cluster upgrades where you have 3 clusters and there is a storage replica between, Hyper-V replica between those clusters, and it demonstrates how you would upgrade the environment from 2012 R2 to 2016. There are demonstrations of Windows 7 2019, like comparing features and roles between 2019 and 2016. There's Labs admin password enterprise or Labs enterprise scenario, so you can take a look how to deploy a local password management solution. The device guard scenarios. There is also bare metal deployment with SCVMM. So take a look there. Try it. There are also videos on YouTube that are also describing some of these scenarios. And once I tried to calculate how many scenarios I have here, and as you can see, the number is crazy. It's like 50 scenarios already in place. Just to take a look on the GIF, which is here, or GIF, which is here, you can see 2 PowerShell windows. This is because I recorded the demonstration that I'm now hydrating 2 scenarios at once. What's actually happening that you are located in the DC domain controller, where in the DC you open 2 PowerShell windows, and what you can do there is you can just right-click with PowerShell into the window while having scenario in the clipboard. This way you can watch what's happening. Like on the right, you can see that now the new volume is being created, and on the left there is a virtual switch being created. So this way you can watch step by step. You can even pause the scripts by selecting portion of the window. If you do select, the script itself will pause, so you can take a look what actually happened in the GUI. Like you can open up CluAdmin, cluster administration, and take a look if you already have a cluster and how it's configured. So you don't need to know PowerShell, but you can easily learn from it, and you can easily grab a portion of the code and reuse it for your purposes, like for real-world deployments. And this is also why I wrote this project, to describe end-to-end deployments. So you can, for example, follow the certification authority example, where I do deploy certification authority with all this IA, or also what I do, I publish CRL with IIS, and in IIS you do this double escaping setting, and also you do IIS remote management, and also you place the correct certificate for IIS remote management. You create proper certificate templates with a PowerShell only, so it's fully automated. You can reuse it for automation of your projects or even for the documentation. So let's talk about simulating storage spaces direct. What you can do with WSLab is that you can simulate 2 to 16 node S2D clusters. It can be converged, it can be hyperconverged. So there are both scenarios where you can have a compute cluster separate from the storage cluster. You can also simulate S2D to S2D storage replica. Means you can have 2 S2D clusters and storage replica in between. It can be managed with Windows Admin Center, as you can see on this GIF file. In this GIF file, you can see that I'm demonstrating connection to this S2D cluster that is running inside my laptop. And you can see there's a lot of stuff here. that you can take a look at. Like you can see error messages like here that one of the servers is running out of the memory, which makes sense because if each of the servers has only 4 gigs of the memory in this case, and it's also running VMs, so there is not much memory left, right? You can take a look on the performance history on the graph. You can see that there are virtual disks and there are also capacity disks. You can see the state of the disks. It's pretty amazing what you can do with this low budget. I mean, you already probably have a computer, so this is for free, right? And you may say, hey, but it's not for free. You have to have your image with Windows Server, right? No, it can be also done in with evaluation versions. So it can be everything for free. And if you would like to use this for your business, like to teach customers how to maintain your environment, how to patch your environment, how to troubleshoot, just feel free. Just grab the scenarios, grab the scripts, and deliver to the customers. So again, the VMs can run inside a cluster, so it's pretty amazing thanks to the nested virtualization. And thanks to the nested virtualization, you can demonstrate almost everything, except there are some limitations. You cannot simulate SBL cache, storage bus layer cache. It means that you cannot have any cache devices. You cannot also have any like million IOPS. It's kind of not possible. Depending what hardware you have, but I guess you will not have a hardware that has so fast storage. Because in my case, I have NVMe drive, which can do thousands of IOPS, but the overhead of the environment itself inside the laptop with just few CPUs I have, it's not so big. So you can have a feel of how it would look like, but don't expect the numbers. It's not meant for production, it's meant for being able to simulate stuff, to be able do troubleshooting, automatization, and validation of your PowerShell scripts. Also, as you can see on the screen, serial numbers are not present for the disks because these disks are VHDs. Let's talk about simulations of S2D networking. You can do converged configurations. You can do even not converged configurations, but these traditional configurations, or even like the old style configurations with traditional teaming for the management NICs. And I also described this in one scenario that is not linked here, but you can find it on WSLab scenarios. You can create converged config like in this example where you have 2 NICs, like double quoted physical NICs, which are basically NICs of the VMs that are simulating S2D cluster. And you can do switch embedded teaming, and then you will create VNIC for management and 2 VNICs for SMB, as you can see now on the GIF. It will configure everything the correct way, where the live migration is the only using SMB adapters, and SMB and live migration is configured to do SMB a live migration instead of compression. You can also simulate the DCB configurations, and also you can try to validate it with a validate DCB. And the limitation here is that you will not be able to apply NetQoS policy, as you don't have physical adapter that supports QoS. So this will fail, and it will also pop up in the validation of the DCB here, because we don't have a real environment. Otherwise, you can do, for example, even VLANs. VLANs are by default configured. There is VLAN 1 to 10. You can use, for example, for connecting machines to some kind of network, to VMs, to some network. Or, for example, SMB is in VLAN 1 in this case, in the default example. If you think about large S2D deployments, it's also possible. On the screenshot on the right corner, you can see that there is a 16 node cluster. It's really convenient if you would like to play with fault domains. Also, it's really convenient if you have scenarios like converge S2D or cluster sets. There are some limitations, and the limitation is that the CPU will go crazy, and the fan of the CPU will go crazy too. So let's talk about simulating failures now. It's pretty easy if you have virtual environment to unplug a cable or even shut down a machine. In this case, you can turn off the machines, and also I'm demonstrating on this GIF that you can easily remove a drive from the physical machine. I mean, double quoted physical machine. So you can take a look what will happen if you remove something or if you shut down something ungracefully, if you reboot something, and so on. I also create one disaster recovery scenario. In this disaster recovery scenario, what you will do, you will have a bunch of machines running inside a cluster. You have a cluster that you will basically dissolve by turning off one node, and then you will replace this one node with a new one. So it will like kind of simulate that you lost operating system and you need to recreate a machine and join it to the cluster. And then I also simulate what will happen if you lose all operating system. It will effectively, you will effectively replace all the operating system drives and build the cluster again. The only thing that will be left are the hard drives. But to make it complex, I will mix the hard drives between the nodes. So it will be random mixed. And then you will be able to see that the rebuild will start to place the data to correct machines. So there's entire disaster recovery process. It also helps to understand what will be needed if something really bad will happen. Let's talk about simulating SCVMM. There's one crazy scenario I created. This crazy scenario can demonstrate first some networks, which is kind of easy. It's just a piece of the code. On the GIF you can see that I select piece of the code, I'll copy it to clipboard and paste it into the PowerShell window. While you can see in the SCVMM window that then logical networks and even IP pools are being created. To be able to run SCVMM, and if you want to hydrate it automatically, you can just populate installation files into the tools VHD folder before running second step, create parent disks. The crazy part of this scenario is this bare metal. On the GIF on the right bottom corner, you can see that I run deploy host region. This will effectively create the deployments, and you will be able to see deployment jobs. And when I start VMs, you'll be able to see that these VMs will grab a Pixie image from the Pixie boot, and they will boot to Windows PE, where they will then connect to SCVMM server, and they will be provisioned automatically. So in this case, these machines are created outside of the DC, so it's on the host. These are created as an empty machine with just some disks, and as you can see, once connected to these VMs, the Pixie boot will kick in. It will download the image, boot the Windows PE, and the process of the applying image will continue. So for simulating storage replica, there's a stretch cluster scenario. It's possible if you will have a failover clustering feature installed, because a failover cluster feature installs shared VHDX filter driver. This filter driver is needed to be able to run machine with shared VHD, and shared VHD is needed because stretch cluster requires disk with persistent reservations. These scenarios are wrote for both 2016 and 2019 servers. In 2019, with Windows Server 2019, you can simulate read-only disk that on the destination side can be popped online. WSLab can also simulate dedicated SR network, so you can have like a feel of how it would look like in the real world. There's also one really nice scenario, which is S2D to S2D. So on the GIF on bottom, you can see that there are two sites, site 1 SR cluster and site 2 SR cluster. Each cluster is running 2 VMs. There are also 2 nodes. There are multiple volumes. In each site, there are 2 data volumes. One is read-only, one is online and second is offline. Actually, it's online with no access. So this is where the replication is in destination mode. While on the other side, there is also one data disk which is online and one data disk which is online but in this special mode where it's effectively offline because it's consumed by storage replica. One is always source and one is destination. Again, 2 VMs. So each site is running 2 VMs and they are replicated to each other. You can also see how it looks like in Windows Admin Center. So you can install Windows Admin Center on Windows 10 machine and then you can navigate to storage replica and see the graphs and how the storage replica is working. So what OS are supported? For the host, you should have Windows Server 2016 or 2019. I use Windows 10, in my case Redstone 5. So I also recommend you to use that. As I saw some weird issues like on 2016 host, ADK refused to install. So to be on the same side as me, I recommend you to run Windows 10. If you will have any issues on other hosts, just create an issue on the GitHub page and I will take a look on it and make sure that you will be happy. For the guests, you can use only 2016 or 2019 machines during the create parent disks PS1 when you will do as a second step when creating domain controller, because domain controller can be only 2016 and newer. It's because of DSC and the way it's written. But there is also create parent disk.ps1 which is located in parent disks folder, but with this one you can create VHD from machines, from ISO files that are 2008 and newer. And when deploying 2012 R2 and older, don't forget that unattend needs to be dejoined credentials. I mean, in hash table you have to define that there should be a dejoined cred instead of the default one, which is blob file. What is the WSLab future? It's up to you. My goal is that WSLab will be running on every engineer's desk. So everything is customer driven, so just let me know what you would like to see, what scenarios you would like to see, what is wrong with the scripts and what's not working well, and we'll make sure that everything will be fixed. There's only one thing to remember. Just right click and run with PowerShell. Like on this cleanup, right click, run with PowerShell, and you are done. I hope you enjoyed this session. I hope you will I will see you in the Slack channel. And if you have any issues, just join the WSLab channel in the Slack and let me know. Have a great rest of the day.